Hello, this is Bonsystems Global. Have you ever looked at our cycloid gear profile and noticed something different? In the world of cycloid reduction technology, there are two main players: the pin gear type and the solid gear type. We call our unique solid gear technology CDC, which stands for Conjugate Dual Cycloid. However, most of you are probably more familiar with the traditional pin gear design. So, what distinguishes these two? And how does Bonsystems Global apply each profile to different industries? Let's dive in. Both gear types have their own unique characteristics. First, let's look at the obvious physical differences. Take a look at the pin gear type. Notice the high part count? A high part count directly impacts productivity during manufacturing. Depending on the gear ratio, you need dozens of pins, rollers, and sometimes even extra bearings. But with our solid gear, all those components are consolidated into a single piece. So, is the solid gear always the better choice? Not necessarily. Each gear profile has its strengths, and they need to be applied to the industry that best suits them. Think of a massive, muscular strongman. While he's perfect for heavy lifting, he'd be at a disadvantage trying to set records in a tight F1 racing car. Now, let's go beyond the visuals and look at the engineering details. Let's simulate both types in motion. In the pin gear, you can see that all the teeth are in constant contact. However, with our solid gear, you can spot a slight relief gap opposite the eccentric shaft. This reveals a lot. If you're an engineer, you probably already know what this means. First and foremost, there is a difference in mechanical friction loss. The journey of energy from the motor to the final output is a tough one. A lot of energy is lost as heat due to friction. We usually measure this in terms of efficiency. In terms of efficiency, the solid gear clearly has the upper hand over the pin gear. However, the pin gear's larger contact area gives it superior torsional stiffness and shock resistance. Let's look closer at another difference. A difference in friction loss inevitably leads to a difference in back-drivability. The solid gear's relatively low mechanical friction directly affects static friction. This results in lower starting torque, which is directly linked to high back-drivability. So, for back-drivability, the solid gear wins again. But as we discussed in our previous content, back-drivability is a double-edged sword. While often essential, in certain heavy industries, high back-drivability can actually create safety risks. If we dig deeper, there are many more differences, but we've covered the three main ones today. Productivity, solid gear wins. Efficiency, solid gear wins again. But for stiffness and shock resistance, pin gear takes the crown. Back-drivability, solid gear wins. But remember, the need for back-drivability depends on your environment. The pin gear's strengths shine in heavy industrial applications. That is why Bonsystems applies the pin gear design to our BSR series. On the other hand, solid gear is the perfect match for robotics, especially humanoids and quadrupedal robots. Does this make the strengths of our BCSA V4 series and Micro series seem a bit more special now?